How are you, my friends? This is Calculus 1 Solved Questions, Finding All Antiderivatives or Indefinite Integrals, Part 2. Please, you can go and check Part 1 for more questions. Just to remind you that the antiderivatives are called indefinite integrals. So the integration of f of x dx is equal capital F of x plus c. This is a constant, if and only if capital F prime of x is equal small f of x. So indefinite integral is also called the most general antiderivative, and this is from lecture 22 of Calculus 1. Now these are four simple formulas for finding antiderivatives. Let's see question number 1. Find the most general antiderivative of the function f of x 2 cosine squared of x minus 1 divided by cosine squared of x. We need the antiderivative. So we can rewrite the function. We can divide each term here by cosine squared of x. So we get f of x is equal to 2 minus 1 over cosine squared of x. 1 over cosine squared of x will be secant squared. So let's find a function whose derivative is 2. This will be 2x. Let's find a function whose derivative is secant squared of x is tan of x. So the most general antiderivative of the given function f is capital F of x, 2x minus tan of x plus capital C. Question number 2, if f prime of x is equal to square root of x times 6 plus 5x and f of 1 is equal to 10, find f of 4. So from f prime here, we need to find the antiderivative, which is f of x. So here we expand first. We multiply square root of x, which is x to the power half, times 6 will be 6 times x power half. This is the same as the given f prime of x, plus 5x to the power 3 over 2. 3 over 2 is coming from 1 here, plus the half. Remember also in the given, we have f of 1 is equal to 10. So the antiderivative will be 6. This is the 6 here. We add 1. X to the power 3 over 2, then we divide by 3 over 2, plus 5, x to the power 3 over 2 plus 1, and we divide by 5 over 2. So when we simplify, we get 4 times x to the power 3 over 2 plus 2, x to the power 5 over 2 plus capital C. To find capital C, we can use the given f of 1 is equal to 10. So this is f of x. So I can replace x by 1. So f of 1, I put here 1, 4 times 1 to the power 3 over 2 plus 2, 1 to the power 5 over 2 plus capital C is equal to 10. This is from the given here. So when you simplify, this is 4 plus 2, that's 6. Take it on the other side, minus 6. So capital C will be 4. So now we need f of 4. The question says find f of 4. So I replace x by 4 in the function f. And also there is a capital C. It happened to be 4. It can be any other number, minus 1 or 7 or 0. So we have 4 times 4 to the power 3 over 2 plus 2 times 4 here to the power 5 over 2 plus 4. So we leave this 4. This one here, we put 2 squared to the power 3 over 2. We cancel the 2. We get 2 cubed, which is 8. This one also 2 squared to the power 5 over 2. We cancel the 2. We get 2 to the power 5, which is 32 plus 4. So multiply 4 times 8 plus multiply 2 times 32 plus 4. You get 100. Question number 3. Capital F of x is equal cosine of 5x minus 2 to the power x plus 1 plus capital C is an antiderivative of a function f. We don't have that function. We have the antiderivative of that function. Find f prime, small f prime at 0. So capital F, as in the given, is the antiderivative of small f. So we have the integration of f of x dx is equal capital F of x plus c. Remember, capital F prime of x always small f. So f of x will be f prime. So we just find the derivative of this given capital F of x. Minus 5 sine of 5x minus 2x to the power x plus 1 times ln of 2. The derivative of c is 0 there. So let's find now, we need f prime. Remember, we need f prime at 0. F prime of x will be the second derivative of the function capital F. So it will be minus 5. There is another 5 from here in the derivative. So minus 25 cosine of 5x minus 2 to the power x plus 1. Also times ln of 2, and there is an L of 2. So it will be all squared. Let's replace x equals 0 in the last equation here. F prime at 0 will be minus 25 cosine of 5 times 0 will be cosine of 0 minus 2 to the power 0 plus 1 times ln of 2 all squared. Remember, all squared. So cosine of the 0 is 1, so that's minus 25 minus 2 times this one here. So ln of 2 all squared, we can leave it like this in the bracket, or we can put the squared on the function ln. So it becomes minus 25 minus 2 ln squared of 2. Question number 4 says if f prime of x is equal to 2 divided by 1 plus x minus 2 divided by square root of 1 minus x squared, and f of 0 is equal to 0, find f of 1. So from the derivative, we have to find the function f. So we can find the antiderivative of f prime. So we integrate 2 to the divided by 1 plus x dx minus the integration of 2 over square root of 1 minus x squared dx. Now, what is the function whose derivative is 2 over 1 plus x will be 2 times ln of absolute value 1 plus x minus 2 there. What is the function whose derivative 1 over square root of 1 minus x squared will be inverse sine of x plus capital C. Let's call this one equation star. Use f of 0 is equal to 0, that's given. So I put here f of 0, 2 ln of 1 plus 0 to be 1 minus 2 inverse sine of 0 plus capital C. So the ln of 1, this will be 0, and sine inverse of 0 is 0, f of 0 is 0, so capital C also is 0. Now we replace x equals 1 because we need f of 1. So I replace in this star here 1, and also I have found that capital C is 0. So it will be 2 ln 1 plus 1 minus 2 inverse sine of 1 plus 0. This is the capital C. So 2 ln of 2, inverse sine of 1 will be pi over 2, and there is a 2 there, so it will be cancelled. So 2 ln of 2 minus pi. This is all the value of f of 1. Question number 5 is an application on acceleration. So this is a particle moves on a straight line with acceleration given by the function a of t is equal 10 sine of t plus 3 cosine of t. If v of t is its velocity function such that v of 0 is equal minus 6 centimeter per second, and we need to find v of pi. So we replace pi in the velocity function. Now this is the given, the acceleration is the given. We need to find the velocity. V of t is the integration of a of t, which is the integration of the acceleration. So v of t will be the integral of 10 sine of t plus 3 cosine of t, all d of t. So it will be minus 10 cosine of t plus 3 sine of t plus capital C. Now here we have to find capital C for the velocity function. We use the given v of 0 is equal minus 6. So I replace t by 0 equals minus 6. So minus 10 cosine of 0 plus 3 sine of 0 plus c is equal minus 6. Sine of 0 is 0, cosine of 0 is 1. So take minus 6 on the other side, minus 10 on the other side becomes 10 minus 6 will be c is equal to 4. So v of t is equal minus 10 cosine of t plus 3 sine of t plus 4. Now let's replace t by pi in the velocity equation here. So v of pi will be minus 10 cosine of pi plus 3 sine of pi plus 4. Cosine of the pi is -1, sine of the pi is 0. So this is 14 centimeter per second. This is the velocity at t equals pi. Question number 6. If the antiderivative of square root of x times x minus 6 is written as ax to the power b plus mx to the power n plus capital C, C is a constant, find the value of ab plus mn. So first we find the antiderivative of this function. Then we multiply the coefficient with the power ab plus m times the n. We get the value for the answer. Now this is the given function. Find its antiderivative, which is the indefinite integral, integration of square root of x minus 6 dx. This is from lecture 22. Square root of x, we can multiply here. It will be x square root of x minus 6 square root of x. This will be x to the power 3 over 2, because x to the power 1 times x to the power half. We add the powers if the base is the same. So it will be x to the power 3 over 2 minus 6x to the power half. Now to find the integration, it will be x to the power 3 over 2 plus 1 divided by 3 over 2 plus 1 minus 6, x to the power half plus 1 divided by half plus 1 plus capital C. This is the constant of integration. Okay, just simplify there. So we get x to the power 5 over 2 divided by 5 over 2 minus 6x to the power 3 over 2 divided by 3 over 2 plus capital C. This is 1 over 5 over 2, which is 2 over 5, x to the power 5 over 2, minus 6. The reciprocal of 3 over 2 will be 2 over 3. We keep here the same power, 3 over 2 plus capital C. Now, this is, we compare it with the given ax to the power b plus mx to the power n plus capital C. So directly I can say a will be the coefficient here, 2 over 5. B will be the power 5 over 2. M will be minus 4. N is the power 3 over 2. So what do I need to find? AB, 2 over 5 times 5 over 2, which is 1, plus Mn, which is minus 6, because minus 4 times 3 over 2. So the final answer is minus 5. Now, for more questions on antiderivatives, please, you can see lecture number 22 in the Calculus 1. And for more questions in general on Calculus 1, you can visit always the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.